Let us now discuss in detail about quantum numbers. These three quantum numbers, that is principal quantum number n, azimuthal quantum number L and magnetic quantum number ml, are used to characterize or describe an atomic orbital. Principal quantum number, it is denoted by the letter small n and it can have values like 1, 2, 3, 4, etc. N denotes the main energy level of an orbital. Thus, n is equal to 1 denotes K shell, n is equal to 2 denotes L shell, n is equal to 3 denotes M shell, n is equal to 4 denotes N shell. Another point is that principal quantum number indicates the relative size of the orbital. Now, an increase in n value also means increase in the energy of the electron in the orbital. Thus, if we have an electron in n is equal to 1, that is K shell, and another electron in n is equal to 2, that is L shell, which electron will be having more energy? It is the electron which is in L shell. Azimuthal quantum number, it is also called angular momentum quantum number. It defines the shape of the orbital. Azimuthal quantum number can have values which range from 0 to n minus 1. Or we can write L is equal to n minus 1. Each energy level is divided into sub-levels. Azimuthal quantum number L defines the shape of the sub-energy level or the orbital. Thus, if L is equal to 0, it denotes S orbital. L is equal to 1 represents P orbital, L is equal to 2 denotes D orbital, L is equal to 3 denotes F orbital. S orbital has spherical shape, P orbital has dumbbell shape and D orbital has double dumbbell shape. For an S orbital, L is equal to 0. So, ml value will be also equal to 0. Thus, we can say that S orbital is spherically symmetric. For a p orbital, L or lambda is equal to 1. Therefore, ml values will be minus 1, 0 and plus 1. How many ml values are there for p orbital? 3 ml values. Which are they? Minus 1, 0 and plus 1. Therefore, we can say that p orbital has 3 orientations. That is, p orbital can have its lobes oriented along the x-axis, y-axis or z-axis. Therefore, we have 3 p orbitals, px, py and pz. Px has lobes oriented along the x-axis, py has lobes oriented along the y-axis and pz has lobes oriented along the z-axis. Similarly, if we consider d orbital, we know that for a d orbital, L is equal to 2 or lambda is equal to 2. Therefore, ml values are minus 2, minus 1, 0, plus 1 and plus 2. Here, in the case of d orbital, how many ml values are possible? 5 values. Therefore, we can say that d orbital has 5 orientations. That is, we have 5 types of d orbital named as dxy, dxz, dyz, dx square minus y square and dz square. N is equal to 1 denotes K shell. If n is equal to 1, L or lambda is equal to 0. Therefore, n is equal to 1 and L is equal to 0 denotes 1s orbital. You should know that an orbital can accommodate a maximum of 2 electrons. 1s orbital therefore can hold 2 electrons. Next, consider n is equal to 2. If n is equal to 2, L can have 2 values, either 0 or 1. Take the combination n is equal to 2 and L is equal to 0. This denotes 2s orbital. Consider the next combination n is equal to 2 and L is equal to 1. This denotes 2p orbital. Therefore, L shell has 2 types of orbitals, 2s and 2p orbitals. For 2s orbital, n is equal to 2 and L is equal to 0. And for 2p orbital, n is equal to 2 and L is equal to 1. You know that according to the formula 2n squared, L shell can have a maximum of 2 into 2 squared, which is equal to 8 electrons. Now, how do we get this number? Let us see. Which are the orbitals possible for L shell, 2s and 2p? How many orbitals are there for 2s? Only one orbital. And you know that an orbital can accommodate a maximum of 2 electrons. Since only one 2s orbital is there and an orbital can accommodate only 2 electrons, number of electrons in 2s will be equal to 2. Next, consider 2p. How many 2p orbitals are there? 3 orbitals. Which are they? 2px, 2py and 2pz. And each of them can accommodate 2 electrons. Therefore, total number of electrons from 2p will be 2 into 3, which is equal to 6 electrons. Thus, from 2s we get 2 electrons and from 2p we get 6 electrons. That makes a total of 8 electrons in L shell. We consider M shell. According to the formula 2n square, the maximum number of electrons in M shell will be equal to 2 into 3 square, which is equal to 18. Now, how do we get 18 electrons in M shell? We know that for M shell, n is equal to 3 and L is equal to 0, 1 and 2. So, take the combination n is equal to 3 and L is equal to 0. From that, we will get 3s orbital. And if we consider n is equal to 3 and L is equal to 1, we get 3p orbital, n is equal to 3 and L is equal to 2, we get 3d orbital. Therefore, M shell has 3s, 3p and 3d orbitals. 3s has only one orbital, therefore number of electrons will be equal to 2. 3p has 3 orbitals. Since it is 3p, which are the p orbitals named as 3px, 3py and 3pz. So, number of electrons will be 2 into 3, which is equal to 6. Now, take 3d. 3d has 5 orbitals and each orbital can accommodate 2 electrons. Since 5 orbitals are there for 3d, the number of electrons will be 2 into 5, which is equal to 10 electrons. Thus, the total number of electrons will be equal to 2 plus 6 plus 10. That gives you 18 electrons in M shell.